Hey physics students, I'm on page 54 of your textbook going over the last few equations in chapter 2. Alright, so turn to page 54. That would be helpful. Before we get started, let's go back over the equations you should know by now. You should know what delta x is. Delta x is the displacement, which is a position, some sort of reference point, final, minus a position, x, initial, where you start, where you end. And you should also know velocity average by now. Velocity AVG, velocity average. And you find velocity average by change in x over change in t. Well, I already showed you what change in x is. Change in t is basically the exact same thing, time final minus time initial. That's what change in t is. Alright. You should also know acceleration average. The average acceleration is change in v over the change in t. I just showed you change in t. T final minus t initial. Change in velocity would be velocity final minus velocity initial. Alright? And we should by now know that the displacement can be found if you don't know x final or x initial. So you can find that by 1/2 velocity initial plus velocity final times change in t. Right. You should also know that the velocity final can be found by velocity initial plus acceleration times change in t. Those are the equations that we've talked about so far. All right. Notice that we have velocity with acceleration here. We've combined the two equations. Is basically what we've done here. All of these equations can be found from these three basic equations. But today we're going to carry on with displacement. Displacement with constant acceleration. And that equation is change in x, which is the displacement, which equals velocity initial times change in time plus 1/2 acceleration times the change in time squared. Now, if you're starting from rest, if you're starting from zero or from rest, you can collapse this equation down to change in x equals 1/2 acceleration times squared. Right? If you're starting from rest. Now, if you turn to page 55, there's some practice problems. Practice problems on page 55. Let's take a peek at number 2. A car, I'm not going to write the entire practice problem summarizing it. A car with a speed 4.30 meters per second accelerates to 3.0 meters per second squared. Find the displacement after 5.0 seconds. Right? That you can find that on page 55. It's not necessary for you to copy that down. I just wanted to give some context for what I was working on and not just throw numbers down. All right. Now, to recap what I just wrote, change in x equals 4.30 meters per second. And all I'm doing now is just plugging all the numbers into the equation. So if we plug all that into your computer, into your calculator, you should get 59 meters. That is the displacement based on the acceleration and the speed after 5 seconds. So here's the 5 seconds, here's the acceleration, and here's the speed. Okay. Now, we could do another practice problem. We could go to number 3 and do one more and see if we have any troubles here. A car travels from rest for 5.0 seconds and accelerates to negative 1.5 meters per second squared. Accelerates at a rate of negative 1.5 meters per second squared. Sorry. How far does the car travel? See, delta x again. Well, I'm going to use the cheat, the starting from rest equation that we wrote down a minute ago, because we are starting from rest. So 1/2 negative 1.5 meters per second squared, that's acceleration, times the time, 5.0 seconds squared. So delta x, or displacement, is you'll find in your calculator is negative 18.75 meters. That's what my calculator gave me. I can't put that down. That would be wrong. Far too many sig figs. Now, there's no indication that it's moving in a positive direction. We just know that the acceleration is negative. So we just know that it moved 19 meters is all we really know. If you put negative, I'd probably forgive you, but 19 meters is what it moved. Okay? Page 56. One more equation. Final velocity after any displacement. That equation is velocity squared final is equal to velocity initial squared plus 2 times the acceleration times the change in x. Notice that there's no time in this equation, and that's the purpose of this. That's the purpose of this new equation. It doesn't have time. However, I should point out here that you must take the square root. You must take the square root to find, or else you won't get the answer. Notice that the square root can be positive or negative. You're going to have to look at the equation to find out whether it's positive or negative. When you plug it into the computer, it doesn't really know which one you want. A car with a velocity of 7.0 meters per second accelerates. This is the review problem that they give right after this equation. I forgot what number it is. Accelerates at 0.80 meters per second squared for a distance of 245 meters. Right? So we want to know the final velocity. So find velocity final. And what is that? Right? Well, velocity final squared is equal to 7.0 meters per second squared plus 2 times 0.80 meters per second, the seconds are squared, times 245 meters. And you'll find when you plug that into the calculator, you'll get 441. But remember, as I said before, you must take the square root of that in order to get 21 meters per second. And that would be a positive.